Hello, everyone. Welcome to the panel on private bridging. We'll talk about what it is, why it should or should not exist, and some ways that we could implement it. Just a quick, brief introduction for each of the people on the panel. If you wouldn't mind introducing yourself and talking about your project in a 1 or 2 sentence summary.
Right. I'm Christopher. I work on NOMA, which I just gave a talk on, so I'll kind of spare you another summary. I also used to work on IBC, which is a completely non-private but very bridging protocol. So it does 100% of the bridging and 0% of the privacy. And as like penance for having brought that into the world, now I'm thinking about private bridging.
My name is Del.
Okay. Hi, my name is Henry. I work on another project called Penumbra. We're building an interchain shielded pool with a DEX that's built into that so that you can privately trade or market make with private on-chain strategies.
Okay, great. My name is Dong Song. I'm a professor in computer science at UC Berkeley and co-director of a new campus-wide center called the Berkeley Center for Responsible Decentralized Intelligence, which focuses on blockchain, Web3, decentralized technologies, and so on. And I'm also the founder at the Oasis Labs, where we build technologies in privacy and blockchain.
Thank you all for coming, and we're looking forward to a great panel. So to sort of start us off, we're talking about private bridges today. And so there's a couple of different scenarios where we have bridges without privacy. We could have a Z. I think it might be unreliable. Check. Okay. Yeah, I think we're struggling with this mic, so. Check. Okay, we're good. So there are a couple of instances where we might want a private bridge, but usually it seems like we're interested in private bridges between two private environments, because if at least one of the environments is not private, then you can do correlation of what goes into the bridge and what goes out of the bridge. And the bridge might be custodial, which is undesirable for reasons. So usually in the context of private bridges, we're talking about a non-custodial bridge, sort of like an IBC transfer, but with some extra features added so that either the sender or the receiver is private. I'm going to check this other mic now. Test. So I wanted to start us off with, I'd like you to each introduce sort of your take on whether you think private bridges should be implemented, how they should be implemented, and where you think they're sort of most interesting or useful.
Okay. I think there is an important distinction to make here between the short-term question and the long-term question. Right now, there is like one production shielded pool, which is reasonably good on Zcash, and it doesn't support multiple assets. So right now, private bridges are kind of like, they're a nice fantasy, but we first need some more shielded pools. I think the long-term question, though, the long-term question of the viability of my microphone, the long-term question of private bridging is one which becomes relevant. Assuming that we do have a world in which most people are transacting within their communities with privacy. And this can be accomplished, at least technically, through Zcash sapling-style shielded pools with some multi-asset extensions, something like this. In this world, we have like a bunch of independent privacy sets. And the reason private bridges are kind of just interesting at all, like why would you care about this, is that privacy is additive and very win-win in this kind of helpful way, such that it seems like there's some tricky technical problems to be solved, but even if people aren't going to agree on who is operating their like community blockchains or whatever, if people can somehow agree on how to transact across them privately, then everyone can be in like one very large privacy pool, and everyone gets like radically better privacy than if they were just in independent community pool. So that's the reason why I think the question is interesting and worth investigating in the long run.
Right, I can talk a little bit about the solutions. So one of the projects that we have been working on is called ZK Bridge. So it proposes a new solution building a truly trustless, permissionless multi-chain interoperability solution. So essentially, in this case, I don't know whether people here are familiar with the ZK Bridge. I can just briefly introduce it. So the idea is to actually build the bridge using succinct proofs. So in this case, anyone can be a relayer that relays a block header from source chain to destination chain. And the relayer, as it relays the block header, also attaches a zero-knowledge proof to show that the block header is correct. And then on the destination chain, there's, we call it an updater contract, which essentially is a verifier, verifies the zero-knowledge proof to verify that this relayed block header is the correct block header. And then with this approach, so as you can see, that is truly permissionless, because anyone can be a relayer, relays the block header, and also it's truly trustless, unlike the current bridge solutions where you have to trust a small committee at a multi-sig, POS, or oracles, and so on. And so those all rely on external trust. But with this ZK Bridge solution, you have no external trust because you verify the zero-knowledge proofs. And also it's truly extensible because in this case, it provides we call it the base layer, provides the interface of the block headers of the source chain. And then on top of that, you can, any application developers can build applications on top. You can do message passing, token swap, NFT, transfer, and so on. So this is a ZK Bridge. And so far for our solution, again, as you mentioned, so because there's not many private chains, so we only design ZK Bridge essentially for, you can call it for this integrity to ensure that the bridge is secure across, just in general you can do it across any chains. But when we consider private chains, then in addition to integrity, you actually want to ensure privacy as well. So we are actually working on an extension. It's not hard, it's actually relatively simple. An extension for the privacy bridge across these private chains, then you can actually preserve the privacy. So here I'm just giving an example of a solution that this type of privacy bridge is possible and it's not too hard to actually build.
So I guess I would start by kind of echoing the point that Chris made of like, well, first we have to actually get to having private chains to bridge between. That's hard, actually, just to build things that are private and also useful. And I guess one sort of maybe slightly contrarian view here is that I feel like actually if you were already in a world where you'd solved that problem and you have multiple different private zones of interaction, it's not totally clear to me that you actually need to have perfect or even particularly strong privacy of transfers between those zones, because if you're already protecting every piece of information other than the actual sort of amount of a transfer, that may be good enough. Not saying that that's true in every application. And there's also a kind of interesting sort of system design question of stepping back from the question of like, what can we make private? Like if we wanted to do like, totally private transfers between these different things, can we do that? Do we actually want to, right? It's actually kind of useful to be able to say, here's sort of the real-time flow between these different parts of a system. You can do things like having, circuit breakers. If you have a bridge and then within an hour, the entirety of the bridge is being transferred over, like that's probably a sign that something has gone wrong. And so it's kind of useful to be able to have some kind of information transmission there. And I think that ties into a really interesting philosophical question of like, at what level should there be privacy versus transparency? For myself, I think I'm pretty motivated by having privacy for individuals, but also when you consider large organizations, there's more of a demand, I think, for having transparency into that. So I think you end up having a kind of, privacy for individual actions, accountability for sort of large aggregates, and perhaps if you have a world where you just have different shielded pools, even if the transfers between those are all public, if you're doing small individual activity, you just kind of get washed away in the noise. If you try to move $1 billion between point A to point B, maybe that's not actually private. And is that a problem? Maybe not.
Thanks for each of your answers. So I just wanted to highlight that one of the differences that I sort of see is that, Henry, you pointed out that there's a degree of fault isolation that we preserve by saying everything within this domain, chain A, maybe we can't see, and maybe chain A and chain B are both private. But if we can see the movement between chain A and chain B, and we know how much value and assets exist on chain A and chain B, so even if Penumbra is, for instance, totally private. Actually, this is a good question. Each of you are working on private chain projects. Would you be able to tell if the total value moved out of the chain exceeded the total value that was on the chain in the first place? That is, would you be able to say there is this much current value locked within the chain, even though that it is private? So that even if you had this private bridging construct, you could say, do this negative check and say, has more value moved off the chain than existed in the first place?
Yes, absolutely. And you can that check is also perfectly compatible with having a private bridge, because part of the sort of proof statement that you're going to make when you do the transfer over is a kind of solvency thing of the net balance of the bridge is still positive. But to the example that I mentioned, you might want to find out before you actually draw all the way down to zero, it might be useful to know that something's going on.
Yeah, I mean, I largely agree with Henry in the sense that I think there's at the sort of more macroscopic levels of scale, a balance to be had between privacy and auditability. I guess, one concern that I have building systems which are trying to be private for users is that it is very hard to know what your users are going to do, and you need to be very defensive, I think, about assuming that your users do not necessarily think through the minutia of the privacy model in every interaction. When users interact with multi-blockchain systems, they click buttons, right? They have their assets on point A and they want it on point C, and stuff happens in between and they want it to be fast, right? Users are not, most of your users, if you want to build a system that's eventually going to reach wide-scale adoption, don't read the protocol, they don't know exactly how it works, and they're going to do whatever the most obvious thing is. And if that is mostly transactions within one zone of privacy or something, then maybe it's fine. And if it's often a lot of complex cross-blockchain interactions and what they're doing is sensitive, then or using identifiable assets or something, then maybe it adds a lot of linkability. So I think it's hard to really make that judgment in the absence of context. And at least one helpful thing we can do as protocol designers is clearly articulate and, where possible, provide options. You always will want fault isolation in a bridge, and the typical, the sort of difficult thing about adding privacy to that, at least in the sort of very strict IBC fault isolation model, is that privacy and fault isolation requires that you handle multi-user private state. So if you're doing just single-user private transactions, that would be fine, but the whole point of a bridge is that you're connecting blockchain, Penumbra to Namada, or something like this, and you care about the whole blockchain not ending up with a negative balance. So people, if they're using a sort of Zcash-style individual privacy from some kind of circuit in ZKPs, they get individual privacy just fine, but that's not that you don't care about their individual transfer amounts balance when they're using the bridge. You care about the overall balance of one chain on the other chain, and you want to test, at the very least, you want to test that doesn't become negative, but, perhaps there's like a more fine-tuned difference, and you want to test that like it doesn't exceed some value within a certain unit of time, right? So it's at least possible to craft, using threshold FHE, for example, it's possible to craft the cryptography to allow, the blockchains in question and the communities in question to choose what granularity of information they want about the transfers going over this bridge and at what frequency, of sort of like batching, what they want to be public and what they want to be private. And I think, again, we do not live in a world of multiple shielded pools yet. This is kind of a long-term problem. But as bridge architectures are kind of terribly difficult to change once you build them, it is at least a problem worth thinking about for the future.
Okay, I can just add to that. I think one thing also, yes, there is, we do need to be careful this trade-off between privacy and transparency. Although the problem is not unique to bridges. Even for private chains, there have been vulnerabilities, implementation bugs, and in those cases also they could go undetected for a very long time. So we are not really dealing with new problems. It's just that with the bridge situation, the problem can propagate to other chains.
Yeah. So to echo that, it seems that all private chains need some auditability, that there can be at least some sense of the total value on the protocol. But to Don's point, there can be errors or there can be bugs in both the bridging implementation, where the fault is not isolated to one environment or another. If the bridge has some bug in implementation that might not be detected, but the same thing could be said that chains have a responsibility, private chains have a responsibility to ensure that their auditing mechanisms allow them to catch economic errors early and often, because those errors could be as equally due to the chain or the bridge. So the next question here is, so we seem to have determined that both chains and bridges can be responsible for this reduction in fault isolation. So the question is, ultimately, how do we gain confidence that for in this model of a private world, a private cross-chain ecosystem, if we're all on one chain, it doesn't matter if the total system of accounting is wrong, because the global system is one system, but we're moving towards this inter-trusted system where one chain must trust another chain's accounting. How does this change our perspective of how we think about the global chain ecosystem? Because just to expand on that question with one more caveat, in the IBC system, we have this system where each chain runs a light client on the other chain. But in this total system of we check each other and we run light clients on each other, how does this change once we introduce privacy and private environments into this ecosystem?
Right. As far as I have seen, actually that part doesn't change. That you can still run light client. Chains like Namada and Penumbra have the state and the transactions are public. They just don't contain the information about transfer amounts or assets or destinations in the transactions. That information is kept off chain. So you can still run the same light client just fine. I think this holds for the ZK bridge architecture as well, as I understand it. I think one interesting question to me that I don't think we've thought a lot about at all yet, just because the systems haven't been deployed in practice, is whether, here we're talking about lines of auditability which are directly aligned with security boundaries, right? So when we have a bridge, there's a security boundary between two different systems. And at that security boundary, certainly if the systems kind of don't trust one another, we probably want to do some auditing. It's not clear to me that those dimensions always should be aligned. We might have some system of, private, a bunch of different private applications on Anoma or on Alio or something like this, which are in the same security domain, but maybe we still want some amount of, it could be just for statistics, doesn't have to be for auditing, but maybe we still want some amount of aggregate data collection that becomes, data that becomes public, which is not individually, hopefully doesn't result in individual identifiability of users, but still allows us to gain some confidence about what is actually going on in this system. And also sometimes like some amount of data about market prices is a very useful signal to get out of a system. And you don't want to make it so private that you can't get that signal out of the system just by virtue of making the individual interactions private. So I think there's a lot of still underexplored design space. Private bridges are just kind of the like very obvious problem, but there are also a lot of more subtle, fine-grained distinctions.
I think a couple points there. So one, as I already mentioned, so with ZK Bridge, we can add a relatively simple extension to enable the ZK Bridge to work across private chains as well. So that we can do. So to answer your other question, in terms of essentially how we need to ensure these bridges, not only that they are designed correctly, but also they are implemented correctly as well. So one thing we are doing is, so we have a ZK collective that actually helps bring the community together to build ZK Bridge as public good. And one of the goals there is we call defense in depth. So basically, here you want to have multiple implementations, prove diversity. So essentially, instead of just relying on one ZK Bridge implementation, you actually have different implementations. And essentially, you have this aggregate solution. And in that case, you can even include other solutions, for example, optimistic bridge and so on, even though they don't have as good trust model. But you can essentially integrate these different solutions to then, in the end, provide what we call defense in depth, so that the overall solution, you have stronger security guarantees. Because for an attacker to attack the solution, the attacker would need to compromise, at least, for example, if you do majority votes, then you need to compromise the majority of these solutions and so on. And to that, I actually want to add, so as I mentioned, so I'm at Berkeley, I'm the co-director of the Berkeley RTI Center. We have been running a MOOC, a massive open online course on ZKP MOOC. You can go to zk-learning.org. This is in collaboration with multiple other institutions as well. Globally, we have over now 3,500 people enrolled in the class. People have been really excited about this. And we just announced that given such a high interest, we actually just announced a ZKP hackathon. It started on March 1st, so this week is enrollment week, so people can sign up to the hackathon, and the hackathon actually goes until May 2nd. And we actually have over $200,000, over $200,000 in prizes in collaboration with different industry partners and sponsors and so on. So the reason I mentioned the hackathon is that actually one of the tracks of the hackathon is ZK Bridge track, where we actually carefully broke down the tasks of building ZK Bridge into very small chunks, so that the hackathon participants, each person, if they only have like a few days or a week's time, they can actually make meaningful contributions. And we hope that by the end of the hackathon, the community together can actually build solutions for ZK Bridge. And this also facilitates the goal of this defense in depth. So we hope that through this hackathon, we can get diverse implementations of the ZK Bridge, and then in the end, we can assemble these different solutions together to actually build actually a much stronger security solution for that.
Yeah. So on the question of how do you develop assurance and verification for these systems, to echo that point, I think it's a social process, and I think you can also see pretty good evidence of that in the ZK systems that have been deployed so far. For instance, with Zcash, where in the original, the first setup ceremony for the original version of Zcash, there was basically a bug, and that bug was found because somebody was preparing slides and looked at it and was like, oh wait, this isn't supposed to be, this variable isn't supposed to be there. And ultimately what that's about is you have to create a group of people who actually care about a thing. You have to create a body of people who have the skill and interest in looking into it, in understanding the properties of the system. And ultimately, in some sense, I think it's kind of a self-solving problem. Like with my hat of like doing Penumbra specifically, it's like, oh God, we gotta, get all this like very correct, and we need to like make sure that these fundamental pieces are really doing what they're supposed to. And that's a kind of an anxious thing. But not with that hat, with the general kind of ecosystem hat, it's sort of like, well, it'll probably be kind of a self-solving problem, because when people deploy ZK systems like that, both like produces and also requires an increased group of people, an increased like size of group of people who work on these things, and also increases the sort of social interest in making them secure. Right? So in any world where any of this works, like you, as a side effect, have a whole body of people who are interested in making sure that it's safe. But
thank you. Now, I'm going to change the topic slightly. There was one point in the discussion in the Twitter thread last year that confused me a bit, and this was the discussion about whether privacy sets, but if you have a bridge between two chains, the privacy set on bridge A and the privacy set on bridge B, well, I'll give the audience a moment to think about this. Are they additive? Are they neutral with respect to one another? Or are they competitive? So the premise, if you even setting private bridging aside, we should have some set of expectations about what is the result of transferring funds from one private ecosystem to another. And so there was some disagreement about whether the privacy sets on bridge A and bridge B should be additive or subtractive or competitive. So I'd like to have Henry and Chris elaborate on their perspective on that point.
Sure. I don't recall exactly what I said a year ago, but I'll tell you what I think now. I think that the anonymity sets are strictly additive, but with some kind of adjustment factor, right? Where if you imagine kind of at one extreme you have two privacy sets and there's a completely private bridge between those, then you get this sort of perfect addition. On the other hand, if every time you have to go from A to B, you have to post your SSN or something, then there's like zero addition factor. And if you're somewhere in the middle where when you do a transfer, it's like revealing some amount, like the asset type, the amount of the asset, then you are leaking some information, but you're not leaking a lot of information. I think there's it's kind of squirrely, so you don't want to rely on that too much. But I think my intuition is even if you don't want to ever make a really concrete claim about you'll have exactly this many bits of privacy, and also users should not have to really think about that. In aggregate, on the whole, if you get actual usage on these two zones, even if you have completely transparent transfers between those, you're still going to have additive effects to the privacy set, even if there's some kind of attenuation of that addition.
Yeah, I mean, it's tricky because privacy is not absolute. Privacy is relative. It's always to a particular observer. And observers in these systems may have more or less information. The default observer who we reason about if we haven't named one is someone who just sees both blockchains and sees the bridge. So they're running a full node or a validator or whatever. They see all the data that's kind of public to everyone. So that's sort of the global observer. But then there might, depending on your threat model, there might be observers who have some private information, right? Or someone you're interacting with using one of these systems, or they know about some certain transactions because they were parties to them or because they bought the data from somebody else. And as you're, of course, as the observer, you care about reasoning for, gets more private information, all else remaining the same. It becomes harder to achieve the kind of privacy you want to them, but this is all very heterogeneous and doesn't simplify. I agree with Henry. There's like a spectrum where if you have sort of two, if you have two transparent systems with a transparent bridge, there's no privacy at all. If you have two private systems with a transparent bridge, there's like some amount of additive privacy depending on to whom, depending on like whether you care about stuff like timing or stuff like exact amounts, depending on the exactitude of the amounts. Like there can be, there's even in transparent bridges, there's some, like do you send it's at 1.6523, USDC. That's pretty identifiable. If you send 5, it's probably less identifiable. There are all these sort of fine-grained distinctions in these systems relating to what the anonymity set an adversary could potentially identify is. All else remaining the same, if you can implement a private bridge, like you definitely don't make it less private, you make it more private most of the time for most users. How much that matters depends completely on context. So I think, we'll kind of just have to see over time. And a good first step is a bunch of private chains with transparent bridges. So I certainly think we should start there. I do think there are like some easy wins, like using lower precision amounts just in wallets or something is an easy win that doesn't require that you build any fancy cryptography. Potentially batching things can be an easy win that doesn't require too much. So there can be some things that don't require threshold FHE or something super heavy duty. But
did you want to speak up, Harry?
Yeah, I have some. So on the easy wins front, it's something that we've thought about a lot for Penumbra, not because of the sort of private to private bridging case, but if you're bridging to a transparent chain, aka the rest of the world as it exists, then you want to have some kind of idea of like how you can reduce the harm. And there's actually a bunch of interesting approaches that you can take that are purely client side and don't require any kind of integration with a protocol or consensus or anything. So, for instance, we have ephemeral addresses. So for every Penumbra account, you can generate these sort of one-time deposit addresses. That way, if you're sending funds across a transparent bridge, from a transparent chain, then that address that will be part of that clear text transfer is this, ephemeral one-time use thing that reveals nothing about your identity. You can also have client software that has some kind of concept of a time preference, right? So you could imagine a user interface where somebody doesn't want to have to worry about, what's my exact amount, blah, 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 but having just like one dial of am I low time preference and I just need this to get done over the next, hour, 8 hours, day? Or do I need this done right now? And if there's an opportunity to have sort of some transfer completed over a longer time period, you could imagine a user agent, a wallet, that would, randomly shard into randomized subamounts that you don't have exact amount leakage, choose some kind of random, Poisson distribution of when to send these individual components. And in that way, even though you're still operating in this kind of transparent world, you're going to have a much larger sort of set of possibilities for that transfer.
That actually leads nicely into my next question. This is directed at Professor Don Song. Since you're actually working on a ZK bridge, to get a little bit into the weeds, I'd like to know a little bit more about the architecture of your ZK bridge and how you would layer privacy on top of that. Whether it maintains privacy in the sense that privacy is a bit overloaded, whether it maintains the confidentiality of what exactly is being transferred between the two bridges, the anonymity of the sender or the anonymity of the receiver, or what components the ZK privacy bridge that you're building is actually trying to achieve.
Okay, yeah, I'm happy to explain. Although before that, I wanted to just add a brief comment to the previous discussion. I think one thing, like this definition, whether the privacy set is additive or subtractive or commutative, I think it really depends on the definition. We do need to be a little careful in the sense that, like, even if you have a great private bridge and a good source private chain, for example, if the destination chain actually doesn't have good privacy, like either has a small privacy set or doesn't just have good design and so on, then when you bridge over it, at the bridging point, you still can maintain the anonymity or privacy and so on. But after that, basically, you suffer from whatever the destination chain provides. So in that sense, I wouldn't necessarily call it additive. So that's why I just said we have to be a little careful with definition. But anyway, so going back to your question, for the ZK bridge, so I explained how the ZK bridge works without privacy. So in there, it's just integrity. So basically, as I mentioned, so anyone can be a relayer to relay the block header from the source chain to the destination chain, and at the same time, it needs to generate a succinct proof. Essentially, the proof does basically need to prove the same thing as like client verification, that the block header is correct. So then on the destination chain, the updater contract basically verifies that proof.
May I interject?
Sorry?
So you said you need to prove that the block header is correct. So would you be running a light client between these two chains?
So in this case, no, the relayer actually needs to, of course, get the block header from the source chain. And then the circuit essentially for generating the proof, what the circuit implements basically is the light client verification. It's the light client verification implemented in the ZK circuit, which then produces the proof. So that's why on the destination chain, the updater contract, so that the destination chain in this case doesn't need to run a light client. It only needs to verify the proof, because when you verify the proof, that exactly you verify that the light client verification has been done on this block header.
Gotcha. So the destination chain doesn't need to run a light client.
Right, so that's the advantage of ZK Bridge, is that you actually significantly reduce both in terms of the architecture complexity, because now on the destination chain, the validators don't need to run a light client for each other source chain, and also it reduces the performance overhead, because now instead of each validator has to run all these different light client verification for these different source chain, now you just run the simple verification, the ZK verification, then it's much easier.
Gotcha.
Much more efficient.
So you could have a ZK bridge without running light clients between the source and destination chain, where the destination chain just verifies the proof of the block header.
Right, exactly. So in this case, you can go both ways, right? Then in this case, neither chains need to run a light client. Only the relayer generates the proof, and the light client verification essentially is implemented in the ZK circuit. So also then goes back to your question. So this, hopefully you can see now how you actually can potentially add privacy into the bridge. Because in this case, we don't need the light client to be run on either chain. And in this case, we need to extend the ZK bridge to include some additional, basically zero-knowledge proofs to show that. So in this case, essentially what it is a bit above. As I mentioned, so the ZK bridge, we view it as there's a base layer that just provides this abstraction or API of block headers. So basically, the updated contracts on the destination chain exposes to other applications this interface of providing block headers from the source chain. And then when you want to do token transfer, for example, over this base layer, then you basically do it on top of it as an application on the ZK bridge, which is pretty easy. As a token transfer, you log token on one side, you mint the token on the other side, for example. Once you have the block header information, then it's pretty easy to build the application on top. And then now when you extend this to in the privacy case, then essentially so basically then you can do this, but with the privacy preserving capabilities as well. So that in that case, you add additional zero-knowledge proof to show. So what you want to show is that then on the source chain, you've locked the token, you've locked your assets, and in this case, for example, in one of our solutions, you actually burn the token in a private way, and then on the destination chain, then correspondingly, once you verify the proofs, you can mint the token and so on. So this, at a high level, this is how you could extend the ZK bridge relatively easily to enable privacy protection.
Now, just to make sure that I understand, this would preserve the privacy of the sender on the sending chain, and would it preserve the privacy of the receiver on the receiving chain?
So then when you mint the token on the receiver side, then you need to take care of the privacy side too, so you need to be careful. So in this case, so what the solution I just described, it actually works in both cases for the destination chain to be either private chain or non-private chain. So when it's non-private chain, you can just mint new tokens. When it's a private chain, the way you mint tokens, essentially you need to do something depending on what the mechanism the private chain, the destination has to basically mint in the private, the privacy preserving way.
And I think we have about 5 minutes left. So if you'd like to wrap up with some closing remarks, now would be the time to do so.
Right, sorry, one quick question. But that does not preserve fault isolation, right? You would have to give that up if...
So that's why I mentioned, so far I've just described a way to build ZK Bridge and also with the extension of privacy preserving. And then if you want additional properties, then we have to discuss the additional properties. But although I still think this fault isolation thing using checking how much amount has been flowing from one chain to another, I don't think that's actually, I mean, that's I guess a bell you can add. But really what you want is to ensure that these bridges are implemented correctly. That's why I talked about defense in depth and so on. So you really need these kind of solutions. Otherwise, you can have other types of vulnerabilities where the bell you added or the monitor you added actually doesn't catch those kind of issues. Right?
Yeah, that's fair. I mean, I guess to tie it into some closing remarks, I think one thing that's kind of really hard, actually, in the blockchain space is that we build security models with crazy long-term feedback cycles. Like, to your point, I mean, IBC tries to solve for fault isolation between blockchains under the assumption that there are going to be many blockchains, and some of those blockchains are eventually going to be Byzantine and crash and not do the wrong thing because of a protocol bug, but do the wrong thing because of social reasons, like the validators are going to defect, right? And so far, I must admit, most of the actual practical problems in blockchains are not of that character, right? They're not problems of intentionally Byzantine actors. They're problems of bugs and problems of kind of these more practical things in the protocol. On the other hand, if we do anything interesting at all, then some of these systems will end up being used for a long time in very large scale social structures. And when your system is being used for a very long time in large-scale social structures, then the kind of real test of your security models comes. And if you didn't design it carefully from the get-go, you're kind of just fucked. And there's nothing you can do once you get to that point because you've already embedded the system into everything, right? So, we have the current banking system security model for the banking system, and it's never going to change. The SEC has spent decades when they had completely the ability to mandate batch auctions and get rid of HFT once and for all. And they just don't do it. These social systems are very, tend to ossify, right? And now is the time to I think it's good basically that there's a diversity of security models. I think that's critical for long-term sustainable usage of this technology, in that some of them are going to fail. Some bridges are going to fail, whether it be due to bugs or eventually due to kind of the security assumptions they baked into their design. Some of these systems are going to fail in the long term, and whether, how conservative you should be right now is maybe less critical than whether as an ecosystem we have a broad diversity of approaches so that we can see over time what plays out, and so that hopefully there are still some systems standing at the end. Hopefully someone was sufficiently paranoid, right? So we'll see how that goes, but I'm glad that there's a diversity of approaches.
I'll keep it short since we are already running late. So I just wanted to mention again, so as I mentioned, we really hope that we can bring the community together to build these secure and universal foundations for multi-chain interoperability, like a ZK Bridge. So we do hope that people can help spread the word about the ZKP hackathon, and also for people here who are developers, we do hope that you could join the ZKP hackathon. So for the ZKP MOOC, you can go to zk-learning.org, and then from there you can find the link to the ZKP hackathon. And also, if you want to learn more information about ZK Bridge, you can just go to zkbridge.org. And again, so we do hope that people can help contribute to build, to have a community-built ZK Bridge solution for the secure and universal multi-chain interoperability.
I guess the main closing thought I have is that I think that we're going to actually see a lot of these problems play out even within the context of individual chains. And I think that that offers the opportunity to have kind of like a technology lab for developing solutions just to the sort of value transfer problem, sort of separately from, okay, and then how do we have this communication between these different systems, which is a problem not just of the sort of consensus guarantee at the technical level, but also consensus at the human level. You know, how do you get different teams to work together, to coordinate on projects, et cetera? If you can build something inside of one sort of scope, it's often a lot easier to say, okay, we've done this experiment, we'll see if this works, and then that can be sort of replicated, broadcast across to other people. One kind of interesting sort of insight there is anytime somebody's actually doing something useful on chain, there's generally some kind of flow of value between different parts of the system, right? Like if you do staking, you have flow of value, you know, to be bonded to different validators. Trading, there's obvious like flows of value there. And in all of these cases, if you want to have sort of a private version of each of those things, you need to have some way to say, here is an individual transaction that contributes some amount of value to this sort of flow between different parts of the system, and this should be able to be kind of aggregated, and you need to be able to verify it, that everything was done correctly. And this is specifically, this is a problem that we've had for Penumbra, where you're trying to do private batching of trades. But it turns out that the types of constructions that you need to build that end up, I think, actually being pretty general. And so my view of where this will go is that we'll see individual experiments in individual chains about, you know, how do you aggregate value and do batching. And then we'll also see developments of like how do you have sort of further and further reduced trust assumptions for bridges, and then those pieces are going to get stuck together, and then, you know, you'll have the opportunity to kind of configure how much information disclosure should there be in this communication system. Should it be, you know, fully private? Should it be fully transparent? Should it be somewhere in the middle? And that's how those pieces are going to come together.
I want to thank each of our guests today, Henry from Penumbra, Don from Oasis, and Christopher from Anoma. Memory name check right there. And I hope this was an interesting conversation as we explored the design space of private bridges and what it could mean for the future. I was particularly excited to hear that we could consider a future where we don't run expensive light clients and still achieve secure bridging of funds between protocols, potentially even in an anonymity-preserving way. So I want to thank each of our guests and our audience.